Okay, quotient rule. Last thing in this section. More complicated rule, a little slightly more complicated proof. Bottom times root of the top minus top times root of the bottom, or the bottom squared. You'll hear me say that a lot, okay? Because you got to practice memorizing it. This is the hardest one to memorize. When I was a kid, I would write it like this. Bottom function, root of the top minus top function, derivative of the bottom over the bottom function squared. I'm not suggesting you do that, but just to be honest with you, you got to memorize this formula. That is the formula. This is it right here. This is the derivative. Oh, I probably should put the box around everything here, right? There's my little thought bubble. There's the quotient rule. You take the bottom function times the derivative of the top minus the top function times the derivative of the bottom, or the bottom squared. That's the rule. Now I'm going to prove it in a minute, but let's practice it, because that's really what you want to be able to do here, right? So if I look at this one here, if I want to do the derivative of this, bottom function, derivative of the top function. You might recognize these are the same two functions, f and g, I used yesterday. Well, actually, same day. I just did this 20 minutes ago in the other video, but you might be watching it on a different day. Who knows? So a bottom times the derivative of the top minus the top function times the derivative of the bottom function all over the bottom function squared. Generally, you simplify this crap, and that's kind of annoying. I mean, technically, that's the answer, right? But then distribute the 2x in, what's that, 10x squared plus 14x. Now, be careful with the negative here, because when you distribute the 5 in, it's negative 5x squared minus 15, right? Because you have to, in addition to the derivative, it's almost like you're distributing a negative 5 in. Well, it's not almost, that's what actually you're doing, isn't it? You're distributing the negative and the 5 in, so you're distributing the negative 5. And so what is that? 5x squared plus 14x minus 15 all over 5x plus 7 squared. That's it. That's the quotient rule, okay? Just by the way, these 3 rules are really super important to make sure that you memorize and can use, and you're gonna have a fair amount of homework on them. But that's it. Those are the 3 rules. Now, why? Because it's kind of weird, right? Like, what the heck did that come from? That seems like a pretty convoluted thing to do, right? I mean, seriously, like, how does this work? Well, okay, let's do the proof of it. Because it's so much fun to do proofs, right? Okay, so here's the deal. F of x plus h minus f of x over h, because that's f of that. Remember, the rule is the derivative is the limit as h goes blah, 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 as h approaches 0 of f of x plus h minus f of x over h. So there it is, right? So what you have to do is you got to get a common denominator here. So what you're going to do is, it's going to be kind of sloppy here, but you're going to multiply this top and bottom by g. I should have left more space there, but I don't want to go back and erase it all. Then you got to start the video over again, it's all kind of sucks. So I'm going to have to live with it. So I get a common denominator. So what do I end up with then? I end up with g h f of x plus h minus f of x g of x plus h all over g of x plus h. There's the common denominator. And then that's all over h. So I'm dividing by this, and then I'm going to divide by h. But dividing by a number is multiplying by its reciprocal. Okay, now I'm going to do that weird thing where I stretch it out, right? Again, I want to stretch this thing out. I'm going to leave this big giant gap here, right? Okay, you got to kind of trust me on that. Little gap. And then I'm going to do something else that's a little weird. You gotta watch this. Okay? It's correct, but it's not weird. If I divide by this and I divide by that, it doesn't matter, right? Suppose I take 100 and I divide it by 2 to get 50, and then I divide it by 5 to get 10. I could have taken the 100 and divided it by 5 to get 20, and then divided it by the 2. So if I have 100 and I want to divide it by 5 and I want to divide it by 2, it doesn't matter what order I do it in, right? Because I'm really just dividing by 10 either way. So here's the thing. If I'm going to divide by the g times g of x times g of x plus h, and I'm going to divide by the h, I can actually divide by the h first. Now you might go, Mr. Why are you doing that? Just because. Same reason I stretch this out. You'll see it. It'll work out. So then what we're going to do here is we're going to subtract f of x, g of x, and add f of x, g of x. So now as long as I do the same thing to both sides, everything's, as long as I subtract the same amount as I added, I'm really basically doing nothing. I'm adding 0 to this whole thing. Okay? So now, okay, and then we'll do that thing where we divide it up right here into 2 different pieces. So I'm going to have g of x, f of x, f of x plus h, right? Minus f of x, g of x all over h. And then on the other side of this red here, I'm going to have another one. F of x, g of x minus f of x, g of x plus h all over h. And then I'm going to be multiplying this whole thing times 1 over g of x plus h. Now, I'm being a little sloppy here, so let me fix this. Now, if you don't do this sometime, and I'm not going to make this proof, but if you forget your limit thingies, I'm not going to penalize you, because I really don't care. But I will tell you, you will run across teachers in your college life that will have a complete conniption because they got nothing else better to do with their life than to worry about crap like that. But yeah, we haven't taken the limit yet, so you're supposed to write it every time you do a new one. And me, I'm just thinking, I always know what's there. I started with it, I haven't gotten rid of it. But just so you know, there we go. So now, we're running out of room here. Should I finish it? I think I have enough room for one more, right? So I got the limit as h goes to 0. I'm going to factor out the g. F of x plus h minus f of x over h. And then I'm going to factor out the g here. No, the f of x here. I have g of x minus f of x, g of x plus h over h. Now remember, this whole thing is in a giant parentheses, and I still have my 1 over g of x plus h. Now I'm running out of room, so I'm literally going to write this last sentence up again. I'm doing it right now as you can't see me, but I'm literally just rewriting that last line over again way up here on the board next to where we're at. You can hear my voice. Just give me a second. I'm just literally rewriting what's there just to give myself some more room, but I don't want to do a step in addition to moving over. Okay, so I'm gonna slide this down now. There we go. There it is. Okay, that was the same thing that was the last one down there. Now, here's the thing. G of x, that's the derivative, right? That's the derivative of f. Now this is where it gets a bit funky. Plus f of x. Now this is where we gotta be careful. Hey, that's backwards. It's supposed to be x plus h. Oh, a minus b and b minus a. 7 minus 3 is 4, but 3 minus 7 is negative 4. Oh, okay, so that's actually the derivative with a negative sign on it, right? And then all divided by g of x plus h. Then I distribute that negative out, and yay for us, we're done. Because now I can let the h go to 0. And there's the proof. There's the derivative. Kind of a pain, but we're done. And it's good to see the proof once in a while. Now you don't have, you guys, I did the proof for the product rule and the quotient rule the past couple of days here. Don't feel like you have to memorize them. It's more like for like, hey, you should at least see it so you realize I'm not making it up, right? I mean, you should know that the power rule, the product rule, and the quotient rule aren't something that just magically appeared. That they can be proven to be true. You don't have to understand the proofs completely, but you should at least see them. Okay, and I think that's it for the week. Okay, so there's only 3 videos for this week. Yay! Save you, you don't have to watch 5 videos, you only have to watch 3.